Hello, nerds. Let's learn some Ruby and things of that nature. So, we're working with data from the Stanford Open Policing Project. Stanford Open Policing Project. And so you can see the URL here. Basically, what they've done is they've gone to a bunch of different data sources from different police departments all around the United States, from a bunch of different cities and states and whatever else, and gotten whatever data they have, and then gotten into various formats to see what records they have, and then they've done work studying this. And so in the wake of the Black Lives Matter movement, I figured it would probably be worth it to go ahead and look at some of the primary data. And I don't want us to sort of have to go and get a hold of, a bunch of records and figure out how to put them into a format. A lot of that work is really hard. It's called data cleaning, and a lot of the data cleaning's already been done by these researchers at Stanford, and so we have fairly clean data in what's called CSV, or comma-separated values files. It's also in another format called RDS, which is like some sort of format usable by R, which is the statistical programming system. We're not really using that. We're interested in Ruby. So we wanted to look for a big Ruby project we could do. We wanted to do something that went with our theme of processing data for the new data science major. So this is what I came up with. And I'm doing everything command line, which you may or may not do. You can use any sort of tool you want, but let me just show you what I've got in my folder here. I've got these basically 3 CSV files. This is Mesa, Arizona, this is Burlington, Vermont, and this is Wyoming. And that's statewide of Wyoming, which I don't know if that means just like all the data that all the police departments in Wyoming have, maybe, or it could be just like Wyoming's Highway Patrol, which is a statewide agency. I'm not really sure. We can look at the README to figure out more. And I have this one here. This is Mesa, Arizona short. Let me run some commands here. So if I do word count -l star CSV, word count is just that word count WC-L just says count the line numbers. So you can see this is only 500 lines. It's basically the first 500 lines of this file. This is 96,000 lines. This is 31,000 lines. This is 173,000 lines. CSV, comma-separated values files. Think of like an Excel spreadsheet where you have column headers and then a whole bunch of rows, and each row will have an entry for each column. So if we do head-n2, head just says show me the first n lines. The -n2 says show me the first 2 lines. So let's look at, for example, the Mesa, Arizona short CSV file. And so if you see what we've got, we have comma-separated raw row number, date, time, location, latitude, longitude, subject age, subject race, subject sex, officer ID, hash. So they've taken the officer ID and applied some hashing function to it so that you can identify the same officer throughout the data, or at least the same officer's ID, but without sort of giving away the officer's actual ID number and so on. Type, violation, arrest made, citation issued, warning issued, what was the outcome, and then some other data. Anything prefixed with raw means there was more information in the raw data, that they're just sort of giving us whatever the raw data was. The rest of it's all been kind of normalized, and the reason for this is police departments don't collect the same data across the U.S. They actually collect very different data. Some of them just have date and time, and that's it, and was an arrest made. Some of them have much, much more detailed data, so it's sort of interesting. And so you can see, you can think of these are the column headers, and then down here, this is the first row. So we see, and it's, row number 1, that's what raw row number means. Here's the date, here's the time, this is the location, this is basically a string. So it's in double quotes. That's because it contains a comma in it. That would be ambiguous if we didn't sort of have these double quotes here. So this is sort of what they had written down, which probably for people that live in Mesa, Arizona, probably oh, the 700 East Franklin Ave. Everybody, East Franklin, everyone knows where that is, or something like that. So, and then, so this is sort of what they had written down, which probably for people that live in Mesa, Arizona, probably oh, the 700 East Franklin Ave. Everybody, East Franklin, everyone knows where that is, or something like that. And so, we can see, a 36-year-old Hispanic female. This was the hash of the officer ID's number. Noise after 10 p.m. to 6 a.m. Probably having a wild party or something like that. I don't know. A citation was issued. I don't know what this means. This is raw charge. I assume that this is like... I actually have no idea what this means. I'd have to go look it up. We're not going to actually mess around with that. Or at least I'm not going to mess around with that in the example things I'm going to show you. So here's what I'm going to show you that I think would hopefully be somewhat interesting. I've got this Ruby file, and let me just sort of show you the basics. So this is like import statements. I'm requiring a whole bunch of different things that we're going to use. The first thing I want to do is go in here and compute what are all the different outcomes. So if you see in here, one of these things is called outcome. Where is it? Here we go. And, down here, the outcome was citation. And I'm like, okay, well, what are all the possible outcomes? I just like to see what they are. I don't need to know how many of them there are. I just want a set where all the possible outcomes that ever occur show up at some point in the set. And so here's the code that I started out with this. So I'm going to make it a function. I'm going to call it outcome types. I'm going to give it a file name. And the reason I'm targeting this at a file name rather than like hard coding in the file name is I've got a whole bunch of different data sets. I've got Mesa, Arizona. I've got Burlington, Vermont. I've got Wyoming's Highway Patrol, which would be a pretty fantastic TV. I grew up watching Chips, the show about California Highway Patrol. What would Wyoming Highway Patrol be like? I mean, like, that's a huge state. People drive really fast in Wyoming. Probably there's a lot of... I don't know what's in Wyoming. I don't think I've ever been to Wyoming. Anyway, moving on. So result here, I'm making it a set. This is just how you invoke a constructor. So set.new. You actually have to require set in order for this to work. So set isn't like sort of like default required. You have to explicitly require it. And then what I'm doing, this is the CSV package. This is sort of like a... what is this? I mean, it's calling a method. This is sort of like a static method or something like that. So we're saying like do the CSV for each on this stuff. And the reason I have that is because I required it up here. There's a whole bunch of other stuff in CSV, but this is sort of what I'm doing. So this is a for each method that's like part of the CSV package. I want to do a for each on the file name, so it'll open up the file name and do the for each on that. I'm saying header's true. Why am I saying that? Well, this has headers in it. It's possible to have CSV data that doesn't have headers, and you have to refer to it by like column number rather than by name. By saying headers, what I'm going to get is each row is going to be essentially a hash where these strings are going to be the keys of that hash. Right, so that's why I'm saying header's true, and I'm saying converters, these are the converters I want to use. And so the numeric means, okay, anything that's just numbers, convert it to an integer, and anything that looks like a date, convert it to a date. So that means that this will get converted to a number, and this will get converted to something of type date. Sadly, this doesn't get converted automatically to a time in any reasonable way that I could figure out. So I have a way of processing that, which I'll show you later when we get to it. So, and then this is this weird, not to say weird, it's probably normal if you're a Ruby programmer. I'm not like a native Ruby programmer, so I'm not like an expert at well, I'm pretty good with Ruby syntax. I wouldn't call myself an expert. But we're doing a for each, and then we're saying, okay, for each, open this thing up. It's got headers. Convert everything you can. What do you want to do for each of? Well, do something with each row. So this is the syntax in Ruby, for each do, and then, these vertical bars, that's like naming the variable. So in Java, this would be like for, string s colon some list of strings or something. In Python, this would be for, s in, some list of strings or something like that. This is sort of the Ruby equivalent, but it's doing a lot more than you could do in one line in Java, because it's also saying like, okay, open up this file name. It's a CSV file because it's a for each in the CSV package. It's got headers. I need you to convert some things. It's actually doing a lot of work for us that, if we were to do this in Java, like it would be a lot more lines of code probably. If we do it in Python, it would probably be... Anyway, we're not going to talk about Python. Another note about these converters, this %i is just telling us, like, go ahead and interpolate these, or don't, basically make them symbols. So I just sort of put a note up here, like this in Ruby is equivalent to this, right? So it's creating a list of the symbol numeric and the symbol date, which would be the same as doing this. And remember, in Ruby, symbols are like strings, but they're immutable. The reason that this ability to have a symbol in Ruby is important is that in Ruby, strings are not immutable. In every other language that we've worked with, C, well, no, never mind. There's no rules to anything in C. Java, C#, Python, strings are immutable. You can't just take a string and change it. In Ruby, you actually can. So if you want to make sure you're getting definitely the thing called numeric, you would have to make it a symbol. And then this is a way of saying okay, everything in here is going to be a symbol and turn it into a list for me or an array. So it'll sort of do that. So it's sort of a weird syntax. There's a lot of stuff here that you may not have seen in other programming languages, but no big deal. So for each thing, go ahead through. Go through each row. What do we want to do? Well, this row, look for outcome, row bracket outcome. This is because each row is a hash. Why is it a hash? Well, because I said it had headers, and that's what for each on CSV does. It goes through each row, so sort of this thing, and each of these things is going to be the value with the corresponding column up here being the key, right? So that's what it does. So when I do row bracket outcome, I'm getting whatever the outcome was, citation or whatever. And then this double, left arrow, this, I'm not sure where they're getting this syntax from. C++ uses these things in various places. Probably other languages do as well. This is just a shorthand for add. So it's saying okay, take whatever this is and add it to my set. And of course, since it's a set, the first time I see citation, that's what I've got. The second time I see citation, it's going to sort of add it. But if you add something to a set that's already there, it has no effect. It was already there. And then at the end, I'm going to return the result. So it's going to return the set. So let me jump down here to essentially my main, and this is a trick you see in Ruby. This is because Ruby is super flexible and dynamic. So this __file __ variable is actually $0. I'm not even entirely sure what this means. I mean, I know what it does. I'll tell you what it does. This is checking that this is the file that's been executed, not a file that's been required. And the reason this is important is if we didn't sort of put it in this, we just stuck all this code at the bottom here, not inside an if, then what Ruby would do is if anyone else required this file, it would just start running the code, which really isn't what you want. When you typically require another file, you want to import all of the functions and all of the classes and things like that. You don't want to just start running whatever the main function is. So by doing it this way, we're saying okay, only if this is the file that was directly executed, essentially this file is main, do this stuff, otherwise don't. So if the file is required, it won't do any of this. What am I doing in here? Well, I've got these three variables, Arizona, Vermont, and Wyoming, and I've got this other, actually, you know what, I'll just call this AZ short. For the one that's only 500 lines long, and then I've got just a whole bunch of stuff here. Well, let me get rid of that because we're not going to do this one first. And so what I'm going to do is go through each of these. So let's look at what happens, and then P, and there's three ways of printing in Ruby. There's P, there's print, and there's puts. It leads to some really funny, puns where you can be I need to pee on line 17. Ha, get it? Pee on. That's pretty funny. It's not actually that funny, but whatever. It's what we have for humor in programming. We don't have that many funny jokes. So we're gonna print the result of calling this, and let's go ahead and run it. So we're gonna say Ruby. What is this called? Example.rb. Let's see. Now, notice it's taking a little while. Interesting. Boom. Seriously, did I forget to save it? I guess I didn't save the file because it just ran this. Well, it's one of the hazards of life. Let's do that again. Oh, wow, yeah, there we go. Okay, good. So, warning, citation, arrest, and NA. Those are the only three outcomes for the Burlington, Vermont data that we have access to. Warning, citation, arrest, or NA. And I assume NA would be like some row of data that Stanford researchers found they didn't really know what to do with. They were like, I don't know, and who knows. And you see this with real world data all the time, right? We give you this weird fiction in computer science classes that, the data is always correct. Data is never correct. Data is always messy. You always have ways of dealing with NA. But so those are the things. So we have warning, citation, arrest, or, we have no idea. And so, I don't know, that's what we've got for Vermont. Now, if you notice, this was sort of taking a little while. Which is kind of irritating. We don't want it to necessarily take a bunch of seconds every time we run it. So that's why I created this file, this Arizona short. Now I realize when I tested this, I tested it with Vermont. Here's what I'm going to do. Watch this. Vermont, I'll just do this. Vermont equal, and then I'm going to do VT underscore Burlington underscore short.csv, and then I'm going to create that file. Watch this. I'm going to say head -n 500 VT blah blah blah, pipe that to VT underscore short.csv. Now if I do word count -l star CSV, yeah, see, now I've got a Vermont. Okay, cool. So I've defined this, but then I've redefined it so that now all of these will run faster. And we can sort of comment and uncomment this depending on which one we want to get. Why are we doing this? Well, having to wait like 5 or 10 seconds or whatever it is just to sort of test to see if the code is correct is really annoying. Test on a couple hundred lines to see if the code runs, like it's syntactically correct, it runs, it doesn't crash. Then once it's running, go ahead and run it on larger amounts of data to see what the actual results are. If you spend all your time trying to process, 500,000 lines of text, and you're just waiting a few extra seconds every time because you don't want to create a short version of the data, you're just wasting a ton of time. So now if we run this, if we go back up to here, we can see, boom, it's done almost immediately. Now, this isn't a complete result. This is just what we saw in the first 500 lines. It happened to cover everything, but it might not. We would need to run it on the full data, right? This is just for testing purposes. I hope that makes sense. Now, I've got two other ways of doing outcome types I want to show you, and then a way to sort of generalize it. So, outcome types, this is just telling us the outcome types, the possible, violation, warning, citation, etc. Here's another way to do it using the inject function. So I'm going to do CSV for each, same stuff here, but then I'm going to tell that to do an inject. What am I injecting into? Well, a new set, and now when we do the do, we have result, which is essentially like this thing each time, and row. And then if we look at this, we're saying result, we'll go ahead and add into that row outcome. And then at the end of this, return result. We actually could do it, believe it or not, could just do it this way. We could just directly return that. I know Ruby has implicit return statements, but I just think that's weird, so I never do it. So we could just actually return this. And let's save that. And now if we come down here and we're like, okay, that was fine, but now let's do this. Let's go ahead and run that. Boom. Same thing. Perfect. Right? So that's just a cool way of using the inject function. It makes the code, where'd it go? Makes the code a little bit tighter, like we don't have to sort of create this and then return it. This gets created implicitly by the inject function. Is this super important? No. It's just kind of, oh, you know what? Damn it. There was a reason why, there's a reason why I have 3 versions of it. This one does the sort of like result equal all of this and then return result. This one just directly returns this. Okay. I'm going to skip going. Obviously, they're both going to work. So I'm not going to go over all of these. We're fine. The thing I want to get to, head-n to Vermont. Nope, Vermont. Blip, there we go. There's a whole bunch of rows, and there's a whole bunch of columns, and the columns have different names. So I want to count, outcomes. I may want to also, I don't know, look at all the possible different values for, I don't know, reason for search or something like that. I might want to check some other thing. And so if that's the case, do I actually, where do I have this? Yeah, any type set. So given a file name and a key, and the key is basically the column header, it does the same thing it did before, but instead of doing row, hard-coded outcome, it does row to just whatever key we gave it. And so, and stupidly, I don't have a test case for this. Any type, well, let's do it this way. Any type set of Vermont outcome. And so I'll go ahead and run that. Boom. You can see Shazam. Check it out. So now, maybe I don't want to just do outcome. I don't know. Maybe I want to do something else. What are the other things we could get? Well, longitude and latitude, that's going to be wild. Let's look at raw race. I don't know. Let's see what... No. And then I'll comment this out. Okay, yeah. So we have white, Asian, black, other, Hispanic, NA, or Native... I assume that means Native American. And this is the raw data just used in Burlington, Vermont. And obviously for the actual value of subject race, if we kind of look at this, any type set Vermont, what is it? Subject race, right? So if we run this again, oh, that's weird. Oh, yeah, because, turns out you have to spell it right. Who knew? Yeah, there we go. You can see that these are the categories that the Stanford Police Project uses across all the different police departments. These are the specific raw categories just used in Burlington, Vermont. Cool. So, the cool thing about this is I didn't need to go and rewrite a for each loop and blah, 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 like I'm doing up here. I didn't have to do all of that. Once I had the function, I was just like, stick in a different column header, boom, we're good to go. So that's what I've got going on there. Now, you're probably looking at this and you're like, okay, Spacco, that's fine to know, violation, arrest, and, citation or whatever, but how many of those are happening? I can already see that's misspelled. Well, let me show you. So that's the outcome types 1, 2, 3, any type set. Yeah, let's do days of week first. So, before we generalize it. So, what I want to know is what days of the week are there traffic stops happening? These are all for, I think these are all traffic stops. Some of them might be pedestrian stops for some cities. Well, there's some sort of police stop. Mostly they're traffic stops. I don't know. It's in the header. It's in the README somewhere for the Stanford Police Project. So here's what I'm going to do. I'm going to create a new hash. This 0 here says, okay, if I ask for a key that doesn't exist in the hash, the default value should be 0. So the same thing, file name, headers, converters, that's great. Do row, sounds good. Date is row of date. Now the dates have been converted to dates because we told it to. Something I know about Ruby, and how do I know this from my, my crack coding skills? Yeah, I Googled a bunch of things until I found it. You can take a date and call this CWDay function on it. Believe it or not, that's a function. Like, you could write it in this way, but in Ruby, you can always leave off parentheses for functions that have no parameters, and for some other types of functions that do have parameters, which I think is one of the hardest things to get used to, is just having all these places where it's like, that's a function? Like, there's no parentheses. Yeah, there's no parentheses. I don't know. It's cool. Anyway, what CWDay does is it takes the date and figures out the day of the week. And so, 1 is Monday, 2 is Tuesday, and so on. So you get values 1 through 7. So, I'm interested, like, are there more stops on Mondays? Are there more stops on Fridays? I would assume there's more on Fridays, but I don't really know. So, let's try out day of week, which is, here we go. I guess I didn't, oh yeah, I guess, I'll come back to this. You go there. And you go here. Good. Let's look at day of week. Okay, so, you know what? Yeah, okay, good. Great, so for that 500 lines of data, this is what we've got. This is a hash. So this is the key, that's the value. Remember, keys are unordered in a hash, so, this isn't in any particular order. But that's not that exciting. I want to put it in order. Watch this. Holy crap. Day of week of the Vermont data set, sort by. So I'm telling it, okay, I want you to sort by. And once you tell a hash to sort, it automatically is going to convert everything into a list of key value pairs. So a list of like tuples. They're not really tuples, they're arrays. I want you to sort by the first thing. This is the symbol first with this ampersand in front of it. It was basically saying like, make that a function, and then I want you to map. And what are we mapping? Well, I want to just get the last thing. So this means sort by the key, but then only display last, which is essentially the value. So now if we run this, here's what we get. Boom. So that would be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Not enough to tell if there's any particular patterns here. Just out of curiosity, I'll comment this out. And I'll run it again and just see if, on the full 36,000 lines or whatever. So you can see it's taking a few seconds. We got to kind of sit here and wait, kill a little time. Boom. So Monday, Tuesday, Wednesday, Thursday, Friday. That kind of makes sense. Saturday, Sunday. So Sunday's the smallest. Friday's the biggest. Saturday's probably the next biggest. And then Monday, Tuesday, Wednesday, Thursday, not as big. I guess that kind of fits. Right? People more likely to be home. Maybe there's less police presence on Sunday. Now, again, this is in Burlington, Vermont. It's a fairly small data set. We'd have to look at much larger data to figure out what we're going to conclude. But, that's something that we can look at. So that's pretty cool. So now, the next thing we want to think about is, okay, that's fine that you can go in here and, tell me all the possible outcomes, but how many of each outcome are happening? And not only that, I don't want to have to write a separate function like for outcomes, how many, and then raw arrays, how many, whatever. I want to just have one function that I can just sort of do anything with. So that's going to be this function. I called it anyType hash. You can tell I did this quickly because the names are terrible. So let's look that up. Where are you? anyType hash. Outcome, 1, 2, 3, anyType set, day of week, anyType hash. There it is. Good. So what are we doing? That's weird. Huh. Great. So the result is, again, a new hash with a default value of 0. We're going to do a for each across everything. And we're going to do result of row of key. Right, so this is the result hash. This is the row hash. And then this is the key. This is the key that we've been given for that row. So it's basically a column header. Plus equal 1, then we return result at the end. Let's run that. Oh, and this is the slower version of it. Well, that's okay. We want to see it for a real amount of data. Let's just sit here and kind of wait a little bit, pretend that everything's fine. Boom. So we got warnings, citations, arrests, and NA. So there's I don't know, a lot more warnings than there are citations, and there's not that many arrests. So that's interesting. We'd have to look at other states, other cities, things like that to figure out, what these patterns look like. And we could maybe break this down by day. When do all the arrests tend to happen? We could sort of combine different things together. From a coding perspective, you just give it a file name for, sort of any of these different city datas that have a particular key in it, and it'll give you back a hash that looks kind of like this. That's kind of cool, right? So we got this one function. We can kind of use that. I'm going to switch this back to the short version just to speed things up a little bit. Okay, outcome, boom. So, and then I have, this is cool. Okay, so you're probably looking at this and you're like, that's fine, Spacco, if you just have outcome, but what about all that cool stuff you did to get the date? What are we going to do about that? How's that going to work? Watch this. So, clearly anyType hash, this will only work if row bracket key directly gives us the value. But remember, if we look up here, day of week, it wasn't just bracket date. It was bracket, date dot CW day. We were saying, like, take this and do something to it. So is there any way to combine all that together? Well, there is. I'm going to write my own function called CW day that takes a date, and it's going to assume that this, and it's just going to return date.cwday, right? So this is my function that's saying, give me a Ruby date, just return the day of week. Just go ahead and call this function on this parameter. So now what I'm going to do here is I'm going to say, okay, I've got a file name, I've got a key, and I've got a function. I'm saying function equal nil because if I'm not given a function, just go ahead and assume function should be nil. There's no way to do function overloading in Ruby like there is in languages like Java and C#. In Java, you can have two functions with the same name but different parameters, and it can differentiate. You can't do that in dynamic languages like Ruby, but you can have default values for parameters. So if I call this with two parameters, it's going to assume the first one's file name, second one's key. I didn't give it a function, so it'll just use the default value of nil. So what am I doing? Well, I'm creating my empty hash. I'm doing my for each just like before. I'm saying, okay, well, my new key is row of key. If the function is not nil, I'm going to take whatever function I was given and call it on new key, right? So in other words, if I'm given this function, which I can call on the key, right, because this is a date, it'll sort of get me back some value, that's what I'll do. This is the syntax for taking a function you've been passed and calling it. You're not really passed a function, you're passed like some proc object and things like that. These are not actually first-class functions, so they kind of operate like it. Right, and so at the end of this, I'm going to have a new key value. It'll, if I wasn't given a function, it'll just be whatever it was, like outcome. It'll be like, citation or arrest or something like that. If I was given a function, it'll just go ahead and call it, and so this will take like a date object and convert it into a key, which would be, or day of week, essentially, like 1, 2, 4, whatever it is. And then boom, there we go, I've got it. And so, it's not super duper exciting, but I can show you, I can show you a couple of things. First, this will just work like before, right? This will work just like this one. I'll go ahead and run it. It should be the fast version. Yeah, boom. We can see totally works. Just like before. So now this function, which couldn't handle a function that was passed to it, well, it's been superseded. I've got this one. And so, but now, suppose I want to pass it, I'm going to switch this back to 2. I can change stuff around. So, yeah, okay. So let's do this. So now we're saying, take the, here's the file name. Use date as a key. This is how you actually sort of pass the function. I'm saying method, and then again this symbol, and then it's looking up my function I wrote that has that name, and it's like, boom, I've got it. Sounds good. And that's going to return my hash. This will do the same trick, sort by the first, so sort by the key, but then only show me the value. And let me go ahead and run this. Boom. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Just what we had before, but with a much more flexible function. Why is this so great? Well, maybe I want to know for these traffic stops or interactions with police, what hour of the day are they having? Right. So if we look at our, data here, I should probably mention when I do, bang head, that's weird. I just made a Quiet Riot reference. None of you are going to get that because you're all students and you're young. There's probably some really funny pun I could do with, like, this is called a bang symbol in programming. It's an exclamation point. So if I do exclamation point head, that's going to find the last command that started with head and rerun it, which, was head -n2, whatever. Anyway, if we look at this, what are we seeing? Well, the time, looked like this. Now, it's probably not that interesting, like, to look at, how many stops were made at midnight and 46 minutes and 0 seconds. But it might be interesting to know how many stops are made, at midnight, at 00 versus 01, 02, 03, to get sort of like a histogram you can imagine of like when police interactions tend to happen. Well, in order to do that, I need to be able to extract just the hour. So I went ahead and wrote a function for that. Now, this won't get converted into anything. It's not a number and it's not a date, so it'll just be a string. I couldn't figure out a way to get Ruby's time function to like convert this. There's probably some way to do it. There's probably like super Ruby programmers who are like, oh my gosh, here's how to do it. But whatever, I'm going to just do this. I'm going to take time, which will be something in this format. I'm going to split on the colon. That'll give me back an array where like this will be the first element, this will be the second element, that'll be the third element. I'm going to take element 0, which is just the hour, and I'm going to do a 2i, which converts a string to an integer, and that's what I'm going to return. So that's my function. So now, look what I'm doing down here. Wait, where did it go? Where is it? I should have uncommented it. I didn't. Yes, here we go. Look at this. Boom. So I'm going to use this any type hash 2, boom, on time, that hour method, which again, this is the way you sort of pass it, and then the same sort by trick and whatever. Let's see what happens. Nope, that's not what I wanted. That's what I wanted. Yeah, there we go. So this is midnight to 1 a.m., 1 to 2 a.m., 2 to 3 a.m., blah, 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 and so on. You know, should be 24 of these. And obviously for like the small amount of data, you're not going to get super interesting results. For the larger data set, and especially as you look across multiple police departments, you might start to see patterns emerge that are going to be a lot more interesting. Okay, so there's one other thing I wanted to show you. Well, two other things, really. You're probably looking at all of this and being like, that's fine, Spacko, for your any hash 2, any type hash 2 that passes its own function. Love it, but I noticed that you're not using inject. What if I wanted to use inject because, like, having this extra line and this extra line is just too much for me? Funny you should ask. That's what I spent much of today on. Here's what this would look like. So, you know, basically this is the same. We're going to say, like, return the result of, like, all of this. Great. We're going to inject with hash.new0. Great. Result in row. Great. This stuff's all the same. This is basically the same, but here's the weird thing. Inject, what it's doing is always saying, like, some new value of result is equal to some modified old value of result. So if we just do this, basically it works for one iteration, and then for the next row, result has been converted into an integer. Why? Well, the result of doing this is actually 1, or, you know, 0, the thing it was before, plus equal 1 is 1. You actually have to put result in here by itself. The result of, you know, this ends up being the hash, and then it reassigns to the new version of the hash the old version of the hash. This was really weird. It took me a while to figure out what was going on here, so that's why I'm not recommending messing around with this too much, but I did want to show it to you because, you know, our purpose here, I mean, obviously we're really excited to be processing data, but our main purpose really is to be learning to do some really cool things in Ruby and to learn to use Ruby, and especially some of the really cool things that Ruby provides that, like, Java's not really going to provide to be really good at, like these for eaches, inject, and things like that. So I want to show you a bunch of stuff. I wouldn't necessarily recommend doing it this way. I don't think this is particularly better than this, and this doesn't have this, like, extra confusing need to have this in here that probably took me an hour to figure this out today. Maybe not an hour. Well, it might have been. I tried a whole bunch. I was like, what the? I had to, like, start printing out what type things were and, you know, all this debugging, and I was like, good grief. Anyway, so, you know, so that's super cool. So, two other considerations as we kind of get to the end of this. The first thing is, you know, as you start to work on larger data sets, you may not want to have one separate function for each thing you're measuring, because each of these functions, this for each, is linear in the number of rows. And if you remember over here, word count -l star CSV, you know, this is the smallest data file we have, 31,000 rows for Burlington, Vermont, and it still takes a few seconds. The Mesa, Arizona data is about 3 times as big. This is like 5+ times as big for the statewide Wyoming data, right? So, and then if you're going to do, like, check the outcomes and then check the officer ID, you know, hashes, and you're going to check the, you know, the time of the week and the day of the week and the hour of the day and whatever else, that's kind of annoying. if you're going to have to like run that for large data files every single time. So I was like, okay, let's just combine it all into one. So here I've got 3 separate hashes for outcomes. Here I am doing, a for each, and I'm updating each of them, and then I'm just sort of putzing them at the end. I'm just printing them out. I guess I could use p here as well. I'm using puts. I switch back and forth. I can't. Both of them append a new line to the end. It's weird that Ruby has p and print and puts. They all have a slightly different semantics. I probably have other places where we get into that. I'm not, you can always Google it if you're concerned. So I'll just sort of, show you that this will do the thing, boom. So like, here's that first thing, here's the second thing, here's the third thing. We computed it all at once. Now, this is just printing it. Like if you actually were processing it, suppose you actually want to do some suppose you're a researcher and, you've been assigned the task of analyzing this data. Well, the goal is not to have like a single program you just run once and it produces everything. The goal might be to have some reusable functions, and first you run it on Mesa, Arizona, then you run it on Burlington, Vermont, then you run it on Wyoming, the Wyoming Highway Patrol. You need to put the results in some format that you can actually sort of look at and read. You may want to put the results in a CSV format, right? Once you figure out what you want to know, and the reason you want to do like this is not that useful because this is just the representation of what Ruby goes ahead and prints. You probably would want to what's called pretty print this, or like put this into a better format. So, as you're processing the data, you probably only want to go through each row of each data file once. You probably don't want to go through it each time for each column you're looking at. You might want to at the beginning, just as you're figuring stuff out, but maybe not long term. And then you probably don't just want to print these out. You probably want to print this, figure out how to print it into some format that's useful, and maybe saving it to a file. So that way when you're comparing Wyoming with Vermont, right, you can just sort of like look at just the data you need to see. So, I don't know, maybe this would be the column heading and this would be one of the entries. Maybe you'd need to convert these into days of the week or something like that. Convert one to the word Monday or something like that. I don't know, whatever you want to do. There's a whole bunch of different options here. I'm just showing you some very, very, very basic tools for getting started on this, but there's a ton more that you can do. And so I'll put a lot of this up on good old GitHub. At least I'll put up the Ruby file. These I don't know. I probably can put them up on GitHub because it's under an open, like reshareable license. But I might not. I'm not sure what I'm going to do to make those available, but I'll definitely get this file available to you to mess with, and I'll try to put it back into, where it starts with just the first one. Cool. Okay. Great. Okay, nerds. Thanks for watching.